All right, so this is the final case study. We did this, or I did this with a colleague 5 years ago, I think. So it's not the most, not the latest in this kind of research, but I still think the data is very interesting. It's not very groundbreaking, but it does show you a little bit of what different kind of data can look like, and that you can apply this approach to almost any kind of system and of idea. So I'm looking at Russian diminutives here, or we were looking at Russian diminutives. She was the native. I did the models, and as you know, probably, or because everyone knows this, Russian has or is somewhat known for having more diminutive markers than nouns. Almost. Not quite, but almost. They have a lot. These are just some of them. So yets, yek, yok, ochik, yechik, yochik. You have a bunch. I will focus on these three here, and there is some systematicity to the assignment or to the partial assignment of these diminutives to different nouns. So, for example, iko, ko, tso, tse can only be used with neuter nouns. Itza and ichka only with feminine nouns. Iko, ok, and chik with masculine nouns. So there are some regularities, but it's much less clear which nouns take ik, which ok, and which chik, so among masculines. And this is where this work lies, only for these three diminutives. The system is quite interesting because, well, there are some nouns which can only be used with one of these diminutives. For example, stol, kot, miach can only take ik, zaur only takes chik, molot and večer only take ok. Other nouns can take two different ones. So stool and shkaf can take ik or chik, rukav, chik or ok, rot, list and chas, ik or ok. It's unclear whether we have good examples for nouns which can take all three. But these combinations are well attested, so the classification is non-trivial. We can sort of organize the system in a hierarchy like this, where we have three main basic classes, and the combinations of these classes gives us the rival classes. And some nouns can only take the single classes, while other nouns can take the rival classes. Or if you prefer, you can say that some nouns can take two of these, but this is the basic organization of the system. The work I'm doing here is based on a previous paper by Guskova and two other authors, let's say et al., and shortened as G&K, where they proposed a quote-unquote new theory of how lexical assignment works, and they call it sublexical phonotactics, but it's basically the same type of analytical classification I've been talking about. They say that speakers encounter forms, and they store these forms, and then they generalize across those forms, and based on those generalizations, they choose they assign new items to the correct classes. Their implementation is called the UCLA Phonotactics Lerner. The details are not very important. Just know that it's quite different from other approaches used in the literature. They compiled a corpus, and we're using that corpus. They were nice enough to send us the nouns. They had almost 1,400 nouns, but we hand checked them, and we had to discard quite a few. there were many mistakes, there were many cases of non-diminutives. So for example, something like alcoholic was there as a diminutive having ik, but alcoholic is just alcoholic, so it ends in ik, but it's clearly not a diminutive. And some things that my co-author thought were non-words. So we ended up with slightly fewer than 900 nouns. This is their distribution across the classes. As I mentioned, we had one example of chick, ik, ok, but my co-author was uncertain about it, what its status. A few examples of chick, ik, a few examples of chick, ok. So this combination of chick with ik or chick with ok is not very common. We have the three main classes, and then the ik-ok combination, which is quite common. Because we don't have enough nouns for these three classes, we had to exclude them, and we only focused on these classes here, these four. Additionally, we found the frequency of the diminutive and the base form using Google Ngrams, and we added that to the model. I will mention that later. So it's hard to evaluate how well Guskova's model work, because they only did their model for a subset of the diminutives. They didn't do cross-validation, and they evaluated the results in a very unsound manner. So it's hard to evaluate it, but we tried nonetheless. We tried to build predictions from their model, and these are the results we got. I couldn't check directly with them if they agreed that this result represents their model. Maybe it does, maybe it doesn't, who knows. But you can see that it's very bad. The model can't really predict anything, so it sort of points towards the Russian system being unpredictable. However, this is only with this UCLA phonotactics learner. So what happens if we try a different approach? Again, we used a neural network, and in this case we added more predictors than just the final letters. We added the length in letters, number of vowels, stress position, stress vowel, and whether the frequency of the diminutive was higher than the frequency of the base. The idea here is that this should sort of capture how transparent the diminutive is, or how lexicalized as a single word and not as a diminutive, which is something that happens sometimes. I don't have good French examples, but I am sure that there are some. A classical example is German Mädchen, which means girl, and it's a diminutive of Magd, but it's been strongly lexicalized, and people don't really feel it as a diminutive. It's just a new noun by now. So that's more or less what we were trying to capture with this idea. So we fitted the model. It's a neural network with a very small one, and it works surprisingly well. These are the results. We get an accuracy of about 0.7, which is much higher than the no information rate, much better than the Guskova's model. And something very interesting happens here, which is, if you look at the confusion matrix, and particularly at the confusion between the ik-ok class and the chick class, you see that it's very low. It's in fact the lowest across the table, meaning now, but however, ik-ok is highly confused with ok and with ik. You can see it here, that this confusion is relatively high. So what this shows you is that the ik-ok class is similar to the ok class, is similar to the ik class, but it's very different from the chick class. And what we saw in the distribution is that the number of nouns which in the classes chick-ik or chick-ok was very low. So there is a sort of mirror effect between the distribution of the data and in the classes and the structure of the class system and what we actually see in the analogical classification. Now, if we were to do the same thing, but we now leave the mixed class out, then we get better results, meaning it's relatively, or it's easier to distinguish between the single classes than between the single classes and the mixed class. Additionally, there is much more confusion between IC and OC, the classes which combine more easily together than IC and CHIC or OC and CHIC. And I think this is also quite an interesting result. Now, so the conclusions of the study: direct analogical modeling outperforms the sublexical phonotactics approach, and the Russian diminutive system is in fact partially predictable from a very simple model. If you were to train a much more complicated model, it is likely that you would get better results. And that's basically it for this study, and we will see each other tomorrow.